So for today, we're going to be working on finding the roots or zeros or solutions of a polynomial using two theorems. We're going to be using the remainder root theorem and factor root theorem. And we're going to be using the skill we learned last week, which is dividing polynomials using synthetic division. And we're going to be using that in our solutions for this week's lesson or today's lesson. But before that, review on synthetic division. So in synthetic division, we're going to change this into coefficients of 2, 3, -2, and 4. And then we're going to divide the coefficients by the 0 of x plus 2. And x plus 2 equal to 0 is x equal to -2. And that is what we're going to be using as a divisor for synthetic division. So by synthetic division, we bring down the first coefficient and we multiply it to the divisor, which is -2. 2 times -2 is -4. And we add them up, and 3 plus -4 is 3 minus 4, which is -1. And then multiply it, +2, add it, 0, multiply it, 0, remainder of 4. And so our answer is going to be 2x minus 1x plus 0x and a remainder of 4 over x plus 2. And the exponent of your final answer is dependent on the highest exponent of your given value. So if this is 3, this is 2, this is 1, and this is 0. And we know that any number raised to 0 is going to equal to 1. So the final answer is simply 2x squared minus x plus 0 plus 4 over x plus 2. So this is the simplest form of our quotient. So this is what we did yesterday. And today we're going to be working on the roots of a function. And to find the root of a function, you need to solve for x, or the solution of a given polynomial. We find the roots of a polynomial. So visually, if we're going to have a visual, let's say we have a graph of a polynomial f of x, and f of x is being graphed in an xy plane, and the xy plane is, let's say, the f of x is looking like this. This is your f of x, or your function, or your equation. And to find the solutions, or the roots, or the zeros, or the point of intersection of the graph on the x-axis, we have 1, 2, 3. So we have 3 real roots in our function, and that is how you visualize the terms we're using in algebra. Because as I've been telling you since day one, you cannot just learn mathematics by learning the process, learning how to do step 1, step 2, step 3. You also need to understand why you're using such process and such steps in finding solutions or answers to your math problems. And this is what we're going to be doing today. The roots of, let's keep it simple, y equals x plus 3. And to find the root of y equals x plus 3, you need to find the point of intersection of x plus 3 along y equal to 0. So all you need to do is to equate y to 0 and solve for it. So to do that, you will have x plus 3 equal to 0, x is equal to -3. And this is your solution. So why is it your solution? Because that will be the point of intersection of your graph on your equation. So let's check. So this is your function. Let's graph it. Y is equal to x plus 3, x plus 3. I'm going to turn this off. I'm going to use this in a little while. and graph of 0. So if you graph it, notice that the line is passing through the x-axis one time, and it's passing through the x-axis at this point right here on the x-axis. And to know what that point is, let's trace it. This is the function, this is the second function, and its point of intersection is at -3. So that's why the solution, as I mentioned a while ago, it's the point of intersection of f of x on the x-axis. Sometimes it's easy to find, sometimes it could be a little bit exhausting to solve for the x-axis. It all depends on the type of functions you are using. So the function is y equals -x squared plus 4. Now we know, without even seeing the graph, that this is a parabola opening downwards. And it's opening downwards because our x squared is negative, or the quadratic term is negative. So how we're going to find the solution of this function? We will set y equal to 0, which means -x squared plus 4 is equal to 0. So to solve for x, all we can do is, since -x squared is negative, I'll just add x squared on both sides. So positive x squared plus positive x squared. So you have 4 equals x squared. And how do we get rid of the square? We we take square roots of both sides. And we know every time we take the square root of both sides, we need to add the plus or minus symbol because we're looking for the solutions of the graph. So we have x equal to plus or minus the square root of 4, which happens to be a perfect square. So it's equal to 2. So if we're going to graph this function, this is a parabola opening downwards, and its solution is at 2 and 2, 1, 2, 1, 2. And the vertex of this parabola, we don't know yet. We have a formula for it, or we can find its derivative, but let's just sketch it. And that will be your solutions, which is x equal to plus or minus 2. So every time you're looking for x, or you're looking for the solution of x, all you need to do is to solve it algebraically or graphically. Graph equation. We find the solution or roots by inspection. We find the solution analytically or using algebra. Which one is easier? Obviously the visual problem, because all you need to do is to look at the point of intersection. So the challenge is how we're going to find the solution of a problem similar to this one. Similar to problem number 4 in this equation. And that is what we're going to be doing today. That you are going to find the remainder of a certain function by just using the solution of your divisor in your equation. For example, for this one, x plus 2 divided by 2x cubed plus 3x squared minus 2x plus 4. If we're going to find the remainder of this function, all you have to do is the solution of x plus 2 is x negative 2. So if we're going to find f of negative 2, we're going to find the remainder of a given function because f of negative 2 is the divisor. So how are we going to prove that? We're going to, this is f of x. We're going to replace x with 2 or negative 2. Bert, Tiffany, Kevin says 4. F of negative 2 is equal to 4, which is the remainder of your function. Magic, right? So that is the remainder theorem, that if you plug in your divisor to your values of x to your function, you'll be able to find the remainder of a given problem involving division of polynomial. I'm going to do synthetic division. I need to have a remainder of negative 59. If it's not negative 59, then that means your substitution is wrong. So this is 1 times negative 3, negative 3. This is positive negative 6. Negative 6 times negative 3 is positive 18. 17. 18 plus 1, 19. 19 times negative 3 is negative 57. And negative 2 minus 57, negative 59. All right, so that is correct. That is correct. So remainder theorem, we're done. Now, factor. So what is the factor root theorem and why do we need to use it? According to the rule, one of your factors in your divisor or as a divisor is going to end up with a remainder of 0. That means that is a verified factor of your polynomial. So for example, how are we going to show that it's one of the factors? We're going to divide it with this, and if our remainder is 0, this is one of the factors, which means its solution or one of its solutions would be x equal to negative 2. 1, negative 5, 2 divided by negative 2. Synthetic division. We're going to prove that this could be, or maybe not, a factor of the function. 2, negative 4, negative 3, positive 6, positive 1, negative 2, 0. So since the remainder is 0, therefore, x plus 2 is a factor of f of x, which means x equal to negative 2 is a solution of f of x. That is another analysis that we have. And as I've mentioned, this is your algebra, it's your gateway to calculus and even statistics, because calculus and statistics, you are required to articulate your answer and make sure that you're understanding the values that you are seeing. And this is basically what we're doing. Now, how are we going to prove that what we are writing and what we are giving in our statements are correct? So if I'm going to graph our function, which is 2x cubed, according to our solution a while ago, x equal to negative 2 is one of the solutions, right? It's in your notes and it's in my paper, but you're not seeing it because I only have one screen right now. And look at the function. This is the graph of your f of x. And look at that. One of their solutions is at negative 2, because that's basically what it means by the factor root theorem. If you divide your polynomial with one of the possible factors, your remainder will equal to 0. Got it? Now, why do we have, how many solutions do we have in this f of x? Can you please tell me? How many solutions or roots do we have in this f of x? Good job. 3. 1, 2, 3. Tell me, why do you think we have 3 distinct solutions in our f of x? Look at the highest exponent. What is the highest exponent in your function?
3.
Yes, that's why.
All right.
So another mathematical theorem that you need to remember, the highest exponent of your polynomial could be the number of roots that you will have in your functions. Now, it's not necessarily have to be 3. It could be at most 3. So the maximum number of roots or solutions that a polynomial can have is dependent on the highest exponent. So if we have an x squared, we could have 2. If we only have an x, you can only have 1. That's why it changes. What I'm going to do is to continuously divide this function. So I have 2, -3, and 1. And I'm going to try out one of the solutions. And one of the solutions is positive 1. What will happen if I have 1 as my solution? 2, 2, -1, -1, 0, remainder. So that means one of the roots is going to be x equal to -2. Another of the roots, or the second root would be x equal to 1. Now, how are we going to mathematically find the last root? This one, this is x squared, and to the 1, so that means this one is 2x minus 1. Because the exponent is going downwards as we divide our polynomial. So from 2, now it's 1, and we're going to equate it to 0, and we're going to solve it algebraically. So we have 2x minus 1 equals 0, plus 1, plus 1. 2x is equal to 1, divided by 2. X is equal to 1/2. 1, 2, 3. 1, 2, 3. And that is how we are going to mathematically compute for the roots of your polynomial. Look at this. 1, 2, 3. 1, 2, 3. All of them are the same. Algebraically and using technology. Because in mathematics, you need to know how to use technology, and you need to understand why technology is giving you this sort of answer in your equation when you're doing your calculation. So the problem here is we don't have any other clues anymore. And remember, in a math problem, the more clues you have, the easier it is to find your answer. Case in point, this one. Easy because the problem is easy. A bit more challenging because the exponent now is 2, or the highest exponent now is 2. That's why the math work becomes a little bit more difficult. When we were looking for the factors or the roots of this function, we were given this. Now look at this. That's the only information we have. We have 3 solutions that we're going to be looking for in this problem. But the problem is we don't have any clue. How are we going to find those x's? We don't even have a graphing calculator to use right now. And Desmos is turned off at this point in our game. So no help on any of your technology. You just need to listen to me so that we will be able to answer this. So let's begin. Find your candidates for your possible solutions. And how are we going to find the candidates for our possible solutions? What are the possible factors of 2? Can you please tell me the factors of 2? Factors of 2 would be 2, 1, -2, and -1. What about the factors of 3? See, if you know the language of mathematics, you can write it as this, which is faster and easier as opposed to this. Both of them are correct, but if you are fluent in mathematics, you'll be able to show notations as many forms as possible. Try it out and see which one will give you a 0 remainder. You have 2 options. You can use synthetic division, or you can do substitution method, which means you're going to plug in the values of 1 to f of x and see which one will give you a remainder of 0. That means if f of 1 is 0, then 1 is equal to the roots, or you can do synthetic division. Do you want to use remainder root theorem or factor root theorem? I'm not going to give you a choice. We're going to use synthetic division, okay? So this is where trial and error would come into play among the 6 factors to use as a divisor. Sometimes we get lucky that we get it on the first try. Sometimes we're not too lucky. Remember, we only need 3 and there are 6 of them. And Tiffany says positive 1. So let's use positive 1. Ooh, look at that. Now we're closer because we found one of them, right? Okay, so now we have 1. We will do it again, but this time we'll make it smaller because now the 0 remainder is right here. So we can just use 2, 5, negative 3 on our next synthetic division. Oscar says 2, and he won. If this is not 0, it's on you. Blame Oscar because he picked the wrong one. Let's see. So no, it's not the solution. So we will move to the next one. So we will still use 2, 5, negative 3. Can you please give me another candidate? Jamie says negative 3. So let's use negative 3. Negative 3 is one of them. Now, when you are only using 2 coefficients left, you don't need to do synthetic division because all you need to do is to use algebra. So we will use algebra because we can translate 2, negative 1, 0 as 2x minus 1. So plus 1. X is equal to 1/2. So the solutions of our polynomials are 1, negative 3, positive 1/2. But the question is, are we correct? Let's see. Negative 3, check. 1/2, check. 1, check. Check, check, check. That's why.
That's cool.
Of course it's cool. You're doubting my coolness?
Oscar Day.
So in mathematics, make sure that you're always understanding why we're doing such process like this, because that's how you understand the language of mathematics. You cannot just memorize steps. You cannot just memorize procedures, because if you're not connecting it to something that is more visual, it would be a little bit too difficult to appreciate mathematics. And once you are appreciating mathematics, that's when you know you are learning and understanding math better. So no extra credit this time. Do you have extra credit? No? No. Let's not give any extra credit anymore. So I'm going to see you all next week. I'm going to post your homework right after this. I'm hungry. As always, I'm starving. Be safe. Keep safe. Try not to get COVID. And don't bully any people. So don't be a bully. All right? Bye-bye. I'll see you all next week. Bye.